In this very video, we are going to be looking at Upthrust and Archimedes principle. Now, by definition, upthrust is an upward force that acts in a liquid. It is the loss in weight of an object when it is dipped in a liquid. It is also called buoyant force or the buoyancy force or buoyancy. Okay. Now, I would like to say here that we experience upthrust in a lot of cases. There are a lot of applications where we see upthrust. One of them is that it's easier to lift an object when it is dipped in water or when it is dipped in a liquid than to lift it ordinarily in air. So what makes it easy to lift an object in water, that is upthrust, is an upward force that acts in every liquid. Water or liquid, oil or liquid. Now, another example is fetching water from the well. You know, when the can is still inside the water, it is easier to draw up. But once the can comes outside the water, it becomes a little more difficult. So the force that allows it, that makes it easy to draw water up, a liquid, is called the upthrust, which is the buoyant force. And it is the loss in weight of object. So you can see a formula here that upthrust is equal to the weight of object in air minus weight of object in the liquid. Okay, so that is to say that the object weight when it is in air is not the same. It's different from the object weight when it is liquid, and that loss in weight is called what? Upthrust. Okay, so we see a question here. It says a metal ball weighs 20 kilogram in air and then 15 kilogram in a liquid X. Find the upthrust in the liquid. Remember, upthrust is a weight. Okay, so we can say that the weight in air is equal to 20 times 10. You remember, weight is mass times acceleration due to gravity. Weight is measured in newtons, while mass is measured in kilograms. Okay, so 20 times 10 here gives us 200 newtons. Okay, now the weight in the liquid is 15 times 10. Okay, that's mg, mass times acceleration due to gravity. That gives us 150 newtons. Okay, so that means the upthrust now will be weight in air minus weight in the liquid, which is 200 minus 150. The answer to that question is 50 newtons. So the upthrust is 50 newtons. We see another question here. It says the loss in weight when an object of weight 10 kilogram is dipped into water is 3 kilogram. The loss in weight when an object of weight 10 kilogram is dipped into water is 3 kilogram. What is the upthrust? Now, you can see that the weight of the object in air is 10 kilograms. Okay? And we can also see that the loss in weight, he said the loss in weight. What is loss in weight? Loss in weight is upthrust. Loss in weight is upthrust, and it means it is equal to 3 kilograms. So you can say your upthrust is the mass mg, which is the 3 times 10, which is equal to 30 newtons. That's quite easy. So following the definition, upthrust is the loss in weight of an object when it is dipped in a liquid. Okay, so we see Archimedes principle. This principle states that when an object is partially or completely immersed in water or in a liquid, okay, or in a fluid, not just, it doesn't have to be liquid, it can be a fluid, that means liquid or gas, it experiences an upthrust that is equal to its own weight. It experiences an upward force that is equal to its own weight. That is according to Archimedes principle. So with this, we get a new definition for upthrust. The upthrust is the weight of the liquid displaced. Upthrust is the weight of the liquid displaced. So, and the weight of the liquid displaced can be the mass of the liquid displaced times acceleration due to gravity. Okay, and the mass of the liquid displaced, remember that density is supposed to be mass over volume. Okay, so that means mass now would be density times volume. So in place of the mass of the liquid displaced, we now have the density of the liquid times the volume of the liquid displaced times acceleration due to gravity. Now you can notice that we have something here. So we can also say that VLD, which is the volume of liquid displaced, is equal to volume of solid that is immersed. So whenever you immerse an object in water or in a liquid, the volume of the liquid that is displaced is always equal to the volume of the solid that is immersed. Okay, so you can see that your MLD here means mass of the liquid displaced, your rho L means the density of liquid, your VLD is the volume of the liquid displaced, and your VSI is the volume of solid that is immersed. Okay, so here now we are asked a question. 20 cm cube of a cubic metal was partially immersed in water. Find the volume of water that is displaced if 1/5 of the mass, if 1/5 of it is immersed in water. Okay, so in that case here, 1/5 of that particular metal is immersed in water. Remember our formula, we are asked to find the volume of the water displaced. So volume of the liquid that is displaced is supposed to be equal to volume of the solid that is immersed. And what volume of solid is immersed is 1/5 of 20 cm cube. That's quite easy. So that's going to be 4 cm cube. So that means the volume of the liquid displaced is equal to 4 cm cube, which is the volume of the solid that is immersed. Okay, we see another question here. It says 20 grams of a solid was immersed in water. If 5 grams of water was displaced, calculate the upthrust in water. That's very simple. 5 grams of water displaced. Upthrust is equal to mass weight of liquid that is displaced. Okay, so that means my 5 gram now, to convert it to kilogram, I can divide by 1000. So that means you have 5 times 1 kilogram all over 1000 gram. Okay, and that is going to give us 0.005 kilogram. Okay, so that means my upthrust now will be mass of the liquid displaced multiplied by acceleration due to gravity. So you're going to get 0.005 multiplied by 10. So that will give us 0.05 newtons. Okay, so that means our upthrust is 0.05 newtons. So you can see the idea here. Even though we are given 20 grams of solid, but has nothing to do with the upthrust in this particular question. So since we are told that the 5 grams of water was displaced, and we know that upthrust is the weight of water displaced, so that means that your upthrust is equal to 0.05 newtons. Okay, so that leads us to another question here. It says, what is the reading on a spring balance when an object of mass 20 grams? What is the reading on a spring balance when an object of mass 20 grams and density 1.5 grams per dm cube is completely immersed in a liquid of density 1.2 grams per dm cube? So we want to know the reading of the spring balance when the object is immersed. Now, the reading of the spring balance when the object is immersed is simply the weight of the object in the liquid. Remember, we say that upthrust is equal to weight in air minus weight in the liquid. Okay, so we can now see here that the weight in liquid, which is what we are asked to find now, will be equal to the weight of the object in air minus the upthrust, making it the subject of the formula. Okay, so at this point here, we can find what the weight in air is. The weight in air is not a problem. It says, what is the reading on a spring balance when object of mass 20 grams? So the weight in air is 20 grams. We just need to convert that to newtons, and that will give us 20 divided by 1000. That's converting to kilogram, then times 10, which is mass times acceleration due to gravity. And that is going to give us 0.2. Okay, so that means if I want to transform grams to newtons, I just divide by 100, and that makes it easier. Okay, so now we need to find the upthrust. From here we can find upthrust, because upthrust is supposed to be equal to the density of the liquid times the volume of the solid that is immersed times acceleration due to gravity. Now if you notice here, the density of the liquid here from the question is 1.2. Okay, so we have 1.2 gram. Now this 1.2 gram per dm cube, if you convert it to SI unit, you multiply by 1000. Okay, so multiplying by 1000 now will give us 1200 kilogram per meter cube. Sorry, this should be grams per cm cube, not dm cube, please. Okay, so we have 1200 kilogram times the volume of solid a mass. If you notice in the question, we are not given volume of the solid, and we are told it's a mass completely, but we are given the mass and we are also given density. So from the formula that density is equal to mass over volume, you can see that volume now is mass over density. So the mass of the solid is 20 grams, which is 0.02. Okay, 0.02 divided by the density of the solid, which is 1.5. Okay, then multiply by acceleration due to gravity, which is what? Which is 10. That's good. So if we multiply this, we are going to get 240 divided by 1.5, or you say 2400 divided by 15, which is divided by 5. That means 160. So that gives us 160 or 16. Sorry, okay, yeah, 160. So 160 newtons. Okay, so we know the upthrust now to be 160 newtons, and we know the weight in air to be 0.2 newtons. Okay, so at this point we can now find the reading. Okay, so the weight of the liquid, which is the tension, so that means we can say tension is weight in air minus upthrust. So the weight in air from what we saw here is 0.2 newtons, then minus the upthrust is 160 newtons, though that's not possible, but we have minus 158.8 newtons. Okay, now we see the question here. It says a metal casting has a mass of 40 kilogram and a volume of 5000 cm cube. Okay, by means of a cord, it is held suspended in oil of relative density 0.76. Find the buoyant force B and the tension in the cord. Okay, so the buoyant force, which is the upthrust, is supposed to be equal to the density of the liquid, okay, now times the volume of the solid, that is a mass, times acceleration due to gravity. So here we see that the density of the liquid is 0.76. That's relative density, and that means 0.76 multiplied by 1000, and that's going to give us 760 kilogram per meter cube. Okay, so we have 760 kilogram per meter cube. So that's what you do. Relative density multiplied by 1000 gives us the density in kilogram per meter cube, times the volume of the solid immersed. Okay, the volume of the solid is 5000 cm cube, which means 5000 multiplied by cm cube means 10 to the power minus 6 meter cube, converting it to meter cube, then times acceleration due to gravity here is 10. Okay, so to calculate that, 760 times 5000 times 10 to the power minus 6 times 10, we are going to get, let's do that quickly. So we have 760, okay, 760 times 5000 times, okay, 5000 times 10 to the power minus 6, then times 10. Okay, let's see the answer. That gives us 38. So that means our upthrust is 38 newtons. Our upthrust is 38 newtons. So that means the whole of this is equal to 38 newtons. Okay, so that now leads us to find the tension in the cord. We said the tension in the cord is equal to the weight minus upthrust. Okay, so you can see the weight here, which is 40. Converting 40 to newtons is going to be 400 newtons. That's mass times acceleration due to gravity. So we are going to get 400 minus the upthrust is 38. Okay, so that gives us 362 newtons. So that's the tension on the string. Thank you very much. Don't forget to subscribe to our channel to get updates of our classes. Have a nice day.